Welcome, dear student, to Beko Virtual School, the school where you study from home, right from your TV screen. My name is Wanda Ronald, and I'm a teacher of physics. Dear Senior 1 student, I'm going to be taking you through physics. The topic we're going to study is measurements in physics. Now, before we study measurements of physics, I believe that you have looked at the introduction of physics before this topic of measurements of physics. Like, for example, why do you study physics? I do not want to go into that. I believe you have already been inducted, have an induction lessons in physics. But now let's talk about measurements in physics. What do we use in measurements? We shall look at these instruments which you see in the picture here. There's a weighing scale, there's a tape measure, there's a clock, there's a thermometer. These are some of the things that are used in measurements in these pictures. And we are going to see what are they used for, which physical quantities they measure, as we interact in this topic of measurements in physics. You are expected to understand some keywords which are going to be used in this topic of measurements. These are some of the keywords you shall have. Estimating, so will be a word often used in measurements. Measuring, fundamental, base, quantities, derived quantities, SI, units, significant, figures, scientific method, density, relative density, and many other words that you will encounter in this topic of ours of measurements in physics. So by the end of this chapter, you should be able to estimate and measure some physical quantities using appropriate equipment and stating the units of what you have measured. You should be able to explain how you chose or how to choose and use the right measuring instruments and the right units, ensuring accuracy. You should be able to identify the potential sources of errors in the measurements you make and devise strategies to minimize them. Continuation, you will also be able to understand in the topic the various methods of presenting data. There we shall be talking about the scientific notation, use of scientific figures in measurements, and the calculations. You should be able to understand the scientific method of investigation. Now, in this topic of measurements, can start by this. Some questions for introduction. When you go to a shop, you buy sugar in kilograms. When you go to a tailor, your cloth, dress or shirt is cut according to your size. Okay, yeah, student, I repeat, when you go to a shop, you buy sugar in kilograms. When you go to a tailor, you take your cloth there, or the shirt, dress, and it is cut according to your what size. What is the general term used to describe the above actions? What is the general term used? There's something you will think, what is that? What is taking place? What is the general term used? Also, I want you to do some simple activity as we introduce our topic of measurements. 1. Write in your rough book situations where measurements are done in our daily life. Dear student, I ask you to be active, and when you read this question, please do the action as well. Write down in your rough book situations where measurements are done in our daily life. Explain what is done in each case. In whatever you have written in one, how is it done? Explain how it is done. Okay, I believe you have some thoughts. We have thought about number 1, you have written down, and after that you've explained how it is done. But I may ask you, what is measuring? What is measuring? How are measurements written down or expressed? After you've measured something, how do you write it down? How do you record it down? How is it expressed? That is all that we are going to understand in this topic of measurements. So, in expressing a measurement, like in the assignment that you have just done, some simple action you did, if you did it. So in expressing a measurement, you assign a value. Okay, and a unit to a physical quantity. A value and a unit. This value here, a numerical value and a unit to a physical quantity. For example, when you measure length, for example, of a table, you are going to tell us whether you have measured that length in centimeters or in meters. Now, the value, if for example we assume that we measured and it gave you 4 meters or 2 meters, so the numerical value is 2 and the unit is the meter, of which physical quantity of length. Okay, so we are going to define a physical quantity like this. A physical quantity is a numerical value and a unit used to describe a measurement. A numerical value and a unit used to describe a measurement. When you go to a shop and buy sugar, you will say, give me 4 kilograms of sugar. So the measurement is 4 kilograms. Okay, and the 4 is the numerical value, and then the kilogram gives us the unit of the physical quantity, and that physical quantity that you will have measured or you will have said to be given is 4 kilograms, which is mass of sugar. Okay, examples include, so the examples of physical quantities, which is a numerical value and the unit which is used to describe a measurement. We can have length, time, mass, volume, density, force, pressure. There are many. Area and etc. You can't complete all of them as we will be studying physics. There are so many. But those are physical quantities which have a numerical value and a unit to describe what? A measurement. Scientific measurements. In this section, you will learn how to measure some basic physical quantities. And the basic physical quantities, there are so many quantities, physical quantities we have in physics, but we have 3 basic physical quantities, and that is length, mass, and time. Length, mass, and time. You will also learn how to derive physical quantities which are obtained from the basic physical quantities. Now, many of the physical quantities that we have are obtained from the basic physical quantities which I have mentioned here. So you are going to understand how do we get the derived, we call them the derived physical quantities, the quantities which are obtained from the basic basic physical quantities. Examples here include area. Like when you get area, is area obtained? You know, area of a box, area of a surface is length times width. Length and width are all measurements of length. Volume, density you can get from mass and volume. Mass and volume. So you're getting it from the basic physical quantity, mass, and then length. Force, and many others. These physical quantities are called derived physical quantities because they are obtained from the basic physical quantities. Modern scientists use the metric system of units called the International System of Units. We shall call this the SI units, standard, the International System, standard international system, the SI units of measurements. Therefore, when measurement of a physical quantity is taken, the quantity must be presented in terms of a numerical value and a unit. Whatever measurement you take, there must be a numerical value and a unit attached to each, which will now describe what measurement has been taken. Okay, now the table below shows a list of some of the physical quantities, their SI units, and the instruments used to measure them. Now here in this table, we are going to look at the physical quantity, the name of the SI unit, the abbreviation, and the instrument. Let us start with mass. The unit for mass, the SI unit for mass is kilogram, and the abbreviation is kg. Which instruments do we use? I believe you have the answers, but you can use a beam balance or a weighing scale. This is a beam balance. So here I have a picture showing you of a beam balance and a balancing scale or a weighing scale. Another physical quantity is length, which SI unit is a meter. And now note here, meter, M-E-T-R-E, and the abbreviation is small letter m, and it can be measured. So many things can measure length, but I just give you one of them, like a meter rule. Meter rule can measure length. I want to emphasize on the unit of meter because some times it is misspelled. When a meter is a unit, it is written as M-E-T-R-E, but when it is an instrument to measure something, then we put M-E-T-E-R. So for now it is a meter, which is a unit of length. Another unit I've begun with the SI units is time. The SI unit of time is a second, and the abbreviation is S, and you can use it to measure using a stop clock, a stopwatch, a stop clock, a stopwatch, a watch. All those are instruments which measure time. Temperature, it is measured in Kelvin, so SI unit, and K is the abbreviation. Of course, you know that we use a thermometer. No, we use a thermometer. There's a mistake here. This is a spring balance. We use a thermometer. Then we have volume, cubic meter, and we use an instrument called a measuring cylinder. Area, square meter. Now I have not put here the instrument because area you have to measure the sides, and the sides are measured by a meter rule or anything which measures length, and then you use a formula to calculate it. And also volume, which I have not put here, okay, but density also kilogram per cubic meter. It's the way we write the units, kilogram per cubic meter, or you can simply write this in our new version of writing units. Okay, so now that is about measurement. And now let's look at measuring and estimating length as one of the first physical quantity that we are looking at, that we're going to look at. Measuring and estimating length. There I give you a picture, and I give you another picture there. Now, would you describe what is happening in these pictures, A and picture B? Describe what is happening. Please, you be active. You write down something. You see, what are you observing here in A and also in B? And there are some of these questions. How far is the nearest trading center from your home? When you leave home to go and buy something from a trading center, how far is it? Could you estimate how far it is? How long is the floor in your room? When you look at the surface of the floor and look at the length, how long is it? How tall is the door? Is the door you are in right now? Look at the door. How tall is it? How high is the roof? When you look up in the roof, how high is it from? Of course, all these you are going to estimate. How wide is the table in your house? When you look at the table, maybe for example, if you are watching this from a laptop, how wide is it? How wide is the surface of the table in the house? Maybe a dining table. All the answers you mention in the response to these questions, which are above here, describe a physical quantity which is called length. All of these answers that you may give by either estimating or by measuring will be giving answers to a physical quantity to describe a physical quantity called length. Now, length. What is length? Length is a distance between 2 points. Is a distance between 2 points. Like we saw before, the SI unit of measuring length is a meter, small letter m. And the metric system is based on other units. However, there are other units of length, but it is based on the units of 10. For example, we have centimeters, where 1 centimeter is equal to 10 millimeters. So these are just other units of length. Decimeters, you may have seen them. We have decimeters. 1 decimeter is equal to 10 centimeters. 1 meter is equal to 10 decimeters. And 1 decameter is equal to 10 meters. 1 hectometer is equal to 10 decimeters. And 1 kilometer is equal to 10 hectometers. So these units are other units of length, smaller or bigger. Okay, just make it smaller or bigger, but the standard unit is a meter. Standard unit for length is a meter. So please, I want you to be active in this lesson that you are viewing by doing some things. For example, at this time, I would love you to pause the player and take some of the following measurements around you. Okay, A, length of a table. You gave the answer by estimating, but if you have an instrument that can be used to measure, like a tape measure or something, you can go and measure the length of a table, the length of your book, the diameter of a cup, and you write down as you answer. The height of the table, how high is it from the floor? The width of the mattress, maybe you sleep on, I want you to experience that. How wide is it? The height of your sister or brother. Now, if you did those, what instruments did you use to make the above measurements? What instruments did you use? So, instruments for measuring length. We have a tape measure. Tape measure. This one is mostly used by tailors. Tailors use this one, but builders use this kind of, which is strong, metallic. This one is somehow on rubber form, but this is metallic. So I wanted to show you the nature of builders in the society. Then we have, in our laboratories, we use a meter rule. So all these are instruments for measuring length. Okay, instruments. Some of these, and we shall see others which are used for measuring smaller length, where a meter rule cannot be used or a tape measure cannot be used. We shall look at that as we go on with the lesson. So now we say that the SI unit of length is meter, but we have other units. But how can you convert? So can you change from one unit of length to another? What do? You can work with a friend. We believe that you have done this before at your lower level, but this is just to make you more active and do something. A, determine how many Roman 1 centimeters are in 1 meter. How many centimeters are in 1 meter? Or you can use the information above. How many millimeters are in 1 meter? How many kilometers are in 1 centimeter? How many kilometers are in 1 centimeter? That is to find how are units of length converted from one unit to another. You have to look at the other metric scale. Convert the following measurements into the units indicated in the brackets. So I'm going to look at an example. Roman 1 want to convert 4.25 meters into centimeters. Now when you check on a meter rule, 1 meter is equal to 100 centimeters. So if a 1 meter is equal to 100, how about 4.5? How about 4.5? This is a mistake here, it's supposed to be 4.25. How about 4.25? So we shall get 4.25 times 100, because 1 meter is equal to 100 centimeters. So we get the 4.25 times 100 to get the answer as, hence 4.25 is equal to 425 centimeters. 425 centimeters. That's example Roman 1. Example Roman 2. If you have 0.256 kilometers, convert it to meters. Then you have to know how many meters are in 1 meter. How many meters are in 1 kilometer? So 1 kilometer is about 1,000. Kilo means 1,000. Kilo. So as kilo, that means 1,000. So 1 kilometer means 1,000 meters. 1,000 meters. So how about 0.256? So we shall multiply like we did in the first example here. We just multiply by 1,000 and they get our answer as 256 meters. Example 3, Roman 3, 6.5 meters into millimeters. Okay, again it says how many millimeters are in 1 meter. If you check, you'll find out that 1 meter is equal to 1,000 millimeters. So get 6.5 times 1,000 until get the answer as 6,500 millimeters. 1 meter, rather 6.5 meters equal to 6,500 millimeters. Okay, and then our last example here, we look at changing now from centimeter to meters. So here in the first question here, we said 1 meter is equal to 100 centimeters. Now here we are coming from centimeter going to meter. So here I say 100 centimeters is equal to 1 meter. How about 1 centimeter? So we get the 1 divided by 100 first. Get 1 divided by 100. Therefore 452 centimeters is equal, now this value 1 over 100 times 452, and we shall get the answer as 452 centimeters is equal to 4.52 meters. Again, I emphasize here that we say we come from a centimeter to the meter, so we say 100 centimeters is equal to 1 meter. Like we did say here that 1 meter is equal to 100 centimeters, so we should just do it the other way around. Change this 100, put it here, change this meter, put it here. So we have 100 centimeters is equal to 1 meter. So how about 1 centimeter? So you have divide by 100, means here when I divide by 100 I'll get 1 centimeter, and here I'll get 1 over 100. So if 1 centimeter is equal to 1 over 100, how about 452? Then I say 1 over 100 times this. This when you simplify, you get 4.52 meters. Okay, 100 meters into feet. Now here I bring in another unit called feet. So how many feet are in 1 meter? Now 1 meter is equal to 3.28. For example, when they are measuring the length of land and the width of land, the common unit used is feet, not meters. Yes, so 1 meter is equal to 3.28 feet. So if I have 100 meters, then I will just multiply by 3.28, and we have hence 100 meters equal to 328 what? Feet. Take that, note that very seriously. Here I just brought in the unit of feet here for you to get also used to this. Then converting from meter to kilometer. Again, how many meters are in 1 kilometer? We said 1 kilometer is equal to 1,000 meters. So we say 1,000 meters is equal to 1 kilometer. Okay, so if I divide by 1,000 both sides, then I have 1 meter on this side is equal to 1 over 1,000 per kilometer. So if I multiply now this 1 over 1,000 by the value, this value here, then we shall get our 679,000 meters is equal to 679 kilometers. Yes, these zeros will cancel out. If you can have a calculator, you can use, and you get the answer 679 kilometers. Good. So that was the conversion of this is conversion of units. Try to get you understand how you convert from one unit of length to another, and at the end of this you will be given an exercise to also practice on conversion of units. Now, estimating length. I remember I asked you questions where you tried to estimate length, and I'm going to give you more. Look at your friend and try to suggest his or her height. And you look at your friend, maybe your brother there, maybe your sister there, anyone and you stay within that house, you can estimate how tall they are. You are estimating the height of your friend. You are just looking at it, and by your eyes you can say this person could be 6 feet, is 7 feet, could be 1 meter tall. Okay, that there you are estimating. So in this section you will estimate how long something is, and then you will measure it to see how good you are at estimating. This is quite interesting. You first estimate by mere observation, and then you will take a step further to measure and see how accurate were you in taking an estimation. Remember, you should always record your work. Remember, you should always record your work. Whatever you measure or estimate has to be written down. Write down all the estimates and measurements you make in this section in a table. You'll be using some of these results later. So please, whatever you do, make sure you put them in a table and write them down. So activity here, which I'm going to give you: find the height of your friend. Just like I have a picture here. How tall are you and your friend? Okay, going to find out the height of your friend. How tall is, maybe ask also a friend to measure your height, and then you find out how tall you are. Okay. What you need a meter rule, a tape measure. If you don't have it, please, you can take some time and get it, either borrow or they can buy, so that you practice. What to do? What will you do? You have to work out with a friend. Don't work alone. Okay. Estimate your height and your friend's height. Remember, with estimation, you don't have to measure directly with an instrument. You assume. You say, when I look at a person, is this tall, is this 7 feet tall. That is an estimation. Then think of a way of measuring your friend's height accurately. So when you're going to measure, look at what are you going to use. Get that instrument and then measure it. Do the same to yourself, or ask a friend to help you, and then record the results. This picture here I have put here is something which was used, or it is even still being used, in measuring land, whereby you just make a stride, a step. Did you know that one stride of a normal adult is about 1 meter? Do you know that? So when somebody makes a stride or a step between the legs, that one is about 1 meter. Depends on how tall you are, but on average it's about 1 meter. And in most cases in the villages, this is how they measure the length of the land when they do not have a tape measure to measure the land accurately in feet. So we just say that is a meter. So record the work. So you are not only estimating and measuring, you are also planning when you think of an appropriate way of doing it. So before you do anything, you must plan. How are you going to do it? And then you know how you're going to answer this question. How did you do it? Maybe you made a mark on the wall. For example, if you're measuring the width or the length, you must have a starting point. You have to make a spot from where you start from. Or the door post at the exact height of your friend. Did you ask your friend to take off his or her shoes first? Give a reason why. So why did you, if you did that, you have to, why did you ask, why did you tell the person to remove shoes? Okay, so estimating the length of land. Estimating the length of land. Like I told you up here, estimating the length of land ordinarily in a rough way, we can just use strides, and one stride is approximately equal to 1 meter, and that is what is commonly done when the tape measure is not available to estimate the length of land. Now, in all those estimations that you have made, and if you have done, let me now talk about accuracy of the meter rule. Measurements are made and they have errors. Okay, what are these errors? What are the causes of these errors? Okay, and how can these errors be corrected? So to to such that we have an accurate measurement. Note that the gap between two successive divisions is 1 millimeter. Now, if we look at a meter rule, these are the divisions or the markings. Okay, so from here to here, it is 1 millimeter wide or 0.1 centimeter. So accurately, a meter rule can measure accurately to a decimal place, to one decimal place, which is can have 0.1 if I'm from here to here, 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, and 2. So the accuracy of this meter rule is to a 1 millimeter or 0.1 centimeters. Which we call, sometimes call this how sensitive this instrument is. Okay, so I do not expect you to use a meter rule and give me two decimal places. Like for example, you say I got 2.2 or 2.34. The second decimal place is just assumed. You cannot put it there. So that is how accurate the meter rule can measure to only one decimal place. Okay, so questions. Discuss with a friend why you think the measurements you made in may not be accurate. How can you make them? So here, after clearing how accurate the meter rule is and you took measurements, so discuss with a friend the measurements that I've been asking you above, whether they were accurate, and if they were not, how can you make the measurements more accurate. So here now it takes us to the sources of errors in measuring length. Sources of errors in measuring length. Why didn't you give correct measurements or write down? Now I will just tell you a few, but you can discover later some on your own. One, I want to talk about what we call the zero error. The zero error, this arises if the end of the rule you are using is worn out and giving rise to a zero error as shown. For example, we know that from between 1 and 2 there are 9 divisions. 1, 2, 3, 4, 5, 6, 7, 8, 9. Then you come to 2. But when you say from 0 here, how many are these? 1, 2, 3, 4, 5, 6, 7, 8. Now 2 divisions have been cut off. So when you use an instrument whereby it is not starting from 0, then you have what we call the zero error. You put an instrument, you will be reading 3.4 something centimeters, but when actually the two divisions beginning from 0 were not there, and that has created what we call the zero error. So always first check the instrument that you are using to make sure that there is no zero error. It is not good to place. So how do we correct it? The zero error, even if you have that instrument which does not start to 0. So it is not good to place the zero end of the rule against one end of the object to be measured and to take the reading at the end. It's always not good. So what do? You should place the object against the rule so that a reading is taken. The reading is made at each end of the object. I'm going to illustrate this. The length of the object is then obtained by subtracting or by subtraction of the two readings. This avoids the zero error in measurement. Now this is what I'm talking about. If I have to measure the length of this block, you can see this instrument here has a zero error. It is broken at the beginning here. So but how do I avoid placing this? I cannot bring this and I put it here. So what I do, I place the object, the block, between two ends, two readings. Here I have a reading which is length, I call this L1, starting from here, which is 2.1234. So this is the first reading here is giving me 2.4 centimeters. Then I come to the end here, I have 5.123, 5.3 centimeters. So when I've obtained these two readings, then you subtract the length of now the block is L2, which is here at this end, one as L1. When I subtract the reading which I get, 2.9 centimeters, is the accurate value for the length of this block. Other than placing it here, it will give me a value which is more or less when it is not what correct. So there I have avoided the zero error mistake. The second the second source of error can be poor calibration on the meter rule, poor markings on the meter rule. Poor markings on the meter rule or on the instrument. I want to illustrate it this way. Now we may have different instruments. I have here. Now this marking here, when you look at the gap between the markings, is wider than this one. Now you take this to be millimeters, and we're also taking this one to be also a gap which is 1 millimeter. So if this is not done accurately, it will cause a poor reading on the instrument, on the object that you are measuring. So this is also a source of when it is not marked well. The calibration is putting these markings here. Okay, it's called calibration. So when it's not done accurately, it will create an error in that measurement, which you may not know, you who is using the instrument to measure. So some instruments may be poorly calibrated by giving a wider or smaller gaps for the same measurement, like the gap of 1 millimeter on the meter rule may not be the same as on the foot ruler. So we find that you are taking both to be 1 millimeter, but actually when the one on the meter rule is wider. That's what I'm talking about. Now the third source of error is what we call parallax error. Parallax error. If the object to be measured is not on the same level as the mark or graduated surface of the rule, the angle at which the scale is viewed will affect the result. It may be reduced by this may be reduced by arranging the meter rule so that there is no gap between the scale and the object. Also, the eye should not be placed at the eye should be placed at the right position for taking readings. Now, what am I talking about here? Here, when you are taking readings, for example, you put the eye should not be put on the side, like in position E1 and in this position E3. When you take this, you will create a parallax error and you not give accurate what reading. So when you are observing, when you are going to take readings, you should have positions E1 and E3 are wrong to view the reading while directly above. Now, while directly above the reading at position is where the eye should be placed for taking measurement. So here the eye should be directly above from the point where you're going to take what the reading, like for this illustration, and there you avoid the problem of no parallax. And also the meter rule there should not be any gap between the object you're measuring and what is being used to measure. You are lifting the meter rule up or ruler up, but you are taking readings that I think this thing here is at this point. That one creates what we call parallax error and gives wrong measurements. Okay, so when you're taking measurements, members, we have discussed the sources of errors and the ways of trying to solve them, and so that you can take correct measurements. However, we talked about the meter rule as an instrument used to measure length, but there are certain lengths which are so small that cannot be measured by a meter rule. Instruments used to measure small length, for example, for very small length like the thickness of an iron sheet or the diameter of a wire. How can you use a meter rule to measure that? Can you use a meter rule to measure the thickness of an iron sheet or the diameter of a wire? Okay, engineers use special instruments called a micrometer screw gauge. There's a special instrument called a micrometer which can measure such small lengths. And here I give you a picture of a micrometer and micrometer screw gauge. Here just have a view of this picture for measuring diameter of a wire and small thicknesses like the thickness of iron and an iron sheet. Okay, there's another instrument which is used here. I still show you micrometer screw gauge. Like for example, here want to measure the thickness here of this, or the diameter of this wire here. Okay, can place here. The wire is placed in between these jaws here, and the instrument is ready. How to read this you'll understand later in physics. I will be using the micrometer screw gauge to measure. As for now, I just want you to know that they are used for measuring small diameters, like the diameter of a wire or small thicknesses. Now they are for bigger objects like the diameter of an iron sheet. Engineers use the vernier caliper. There's some thickness which is slightly bigger than the diameter of a wire, but still smaller than what a meter rule can measure. So we use a vernier caliper. It is used to measure. We can use vernier caliper. For example, this one can be used to measure to internal and external diameters of test tubes. For example, a test tube. Now, this is a picture of the vernier caliper. These jaws up here are used to measure the internal diameter, and these ones are used to measure the external diameter. So for measuring diameter of such objects such as test tubes and cylinders, inner and outer diameters. So we use vernier caliper. If we're in a lab, I would pick this and show you, but for now this is the structure of the vernier caliper. Okay, and here when you're using to measure outside diameter, the outer diameter, we use this lower jaws put here, and then you take readings from this scale here. Okay, and then when you use to measure the inner, you see those jaws are now put inside here, and this measure the inner diameter of the test tube. Okay, thank you very much for listening. Our lesson ends here, and we shall later look at how can we measure area and the volume as other physical quantities. Today I have concentrated on the length, and you have seen the instruments which are used and conversion of units, plus those few terms. I hope that you become active as we do, because in this current syllabus we shall require you to participate, and each assignment given, please make sure you do it. Thank you for watching and listening to me.